We like to think of the solar system as a frontier. A place of firsts. First footprints on the moon. First rovers on Mars. First probes to the outer dark. But what if we are not the first? What if every planet, every moon, every quiet rock in the dark, is a headstone? Not for one lost civilization, but for many. This is the story of how 3 people, 1 ship, and 1 impossible dataset forced us to confront a terrible, beautiful possibility. The solar system is a graveyard. The Cairn was not a glamorous ship. An old exploration and salvage vessel, it spent most of its time chasing derelict probes, retrieving samples, and doing the kind of science that never makes the feeds. Captain Soren Hale liked it that way. Soren had grown up on the orbital habitats above Earth, watching launch trails rise from a planet still recovering from climate collapse. He'd flown fusion tugs in the Jupiter trade, lost 3 friends to a docking accident, and traded a cushy corporate job for the quiet of the outer belt. If there was one thing he hated, it was surprises. Which made the message from Mnemosine particularly unwelcome. Mnemosine, MNEM, to the crew, was Cairn's AI. Specialized in pattern recognition, it handled navigation, sensor fusion, and the 1,000 micro-tasks that kept humans from making tiny, fatal mistakes. Captain, I have flagged an anomaly in Trojan Sector L4 Jupiter. Recommend course correction, MNEM said, voice calm as ever. Soren frowned. Trojan Sector meant the Jupiter Trojans, swarms of asteroids trapped near Jupiter's Lagrange points, where gravity balances in stable wells. In a 2-body system like Sun-Jupiter, there are 5 points in space, L1 to L5, where gravitational pulls and orbital motion line up just right. Objects at L4 and L5 share Jupiter's orbit, leading or trailing it like packs of wolves. They're primordial time capsules. Rocks that have barely changed since the solar system's birth. But this Trojan wasn't just a rock. Not to NEM's algorithms. Dr. Amira Saul was a planetary geologist and something rarer, a planetary archaeologist. She'd made her name analyzing odd layering in Martian sediments, finding microfossils that proved Mars once had not just water, but something like a biosphere. When Soren patched in NEM's analysis of the Trojan anomaly, her eyes narrowed. The target was catalogued as 1173, Talia, a 90-kilometer carbonaceous asteroid in Jupiter's L4 cloud. But under radar and gravimetry, Talia didn't behave like a solid rock. It had a perfectly spherical high-density core about 500 meters across. A surrounding halo of loosely bound rubble. And a set of weak, regular radio echoes at millimeter wavelengths. Artificial? Not necessarily. Gravity can round things. Natural masers exist. But all 3 together? That was enough to get Amira excited, and Soren nervous. Cairn diverted. Days later, they were parked 50 kilometers off Talia, engines cooling to a whisper. Amira suited up with a small team, taking a tunneling drone for company. They descended toward the core. The outer rubble was what you'd expect, fractured chondrite, ancient carbon, hydrocarbons frozen into stone. At 300 meters down, the drone's drill hit something else. Contact layer, Amira reported. Density jump. Composition. MNEM? High-purity nickel iron with trace vanadium and molybdenum, MNEM replied. Crystalline order inconsistent with natural formation. In other words, refined metal. Not ore. The tunneling drone switched heads, boring through the metal shell. It broke through into a cavity. Inside was vacuum. And something else. A spherical chamber, half a kilometer across, lined with panels. In the center floated a fractured, skeletal structure, like the ribs of a shuttered telescope. Amira's helmet light traced delicate latticework, broken struts, and what looked like petals folded in on themselves. Her breath caught. "It's a telescope," she said. Or it was. A telescope inside an asteroid. At Jupiter's Trojan point. Watching what? MNEM overlaid the structure's axis on a star map. The answer was obvious and unpleasant. The long axis pointed roughly toward the inner solar system. Toward the Sun. Toward Earth's orbit. There's a dead observatory buried in a Jupiter Trojan, she thought. News like that doesn't stay on one ship. Within weeks, a full expedition assembled in Mars orbit. Cairn was reassigned as lead platform. Amira got what she'd always wanted: resources, priority, and the biggest puzzle of her career. She also got Dr. Keiji Nakamura. Keiji was an astrophysicist, but his specialty was technosignatures and deep time. He'd spent years arguing about the Silurian hypothesis, the thought experiment that asks whether an advanced civilization could have existed on Earth millions of years ago and left almost no trace. Over millions of years, plate tectonics recycles crust, erosion grinds mountains, and ice ages reset landscapes. Most built structures vanish in less than 1,000,000 years. Only certain footprints survive. Unusual isotope ratios, synthetic molecules, deeply buried artifacts, things placed off-world. The best way to leave a message for deep time might be to put it where geology can't touch it, like inside a stable Trojan asteroid. "That shell is old," Keiji said, running his fingers over spectral plots in his notebook. "Cosmic ray damage, micrometeoroid cratering on the inner surface, Amira. This thing's been dead for at least 1 billion years." "1 billion?" Soren repeated. Humans weren't even a bad idea in a fish's brain yet. It predates complex life on land, Keiji said. Whoever built it wasn't watching us. They were watching something else. And we just happened to drift into the crosshairs later. Amira and her team began disassembling the core. They found shattered mirrors of a material stronger than any human-made glass. Superconducting coils fused into inert metal. A central vault, a sealed pod at the geometric center. They brought the vault aboard Cairn. It was roughly the size of a small car. Smooth. No seams. MNEM got to work. After days of non-invasive probing, MNEM found the trick. The vault wasn't locked by force. It was locked by pattern. Specifically, by a particular arrangement of orbits and timings, a celestial combination lock. Planets and moons often fall into orbital resonances. Simple ratios like 2:1, 3:2 between their orbital periods. These resonances are stable over long timescales. If you wanted to make a lock that only opens when a system had reached a particular configuration, you could use resonances as your dial. MNEM determined that the vault's activation pattern corresponded to the orbital periods of Jupiter, Saturn, and a small inner rocky world that used to orbit close to the Sun, a world long gone. Mercury? Soren asked. Too close, Keiji said. This configuration died when the Sun's early magnetic winds migrated orbits. We're looking at a lock that can no longer be opened by its intended makers. But, MNEM added, the lock also responds weakly to modulations in the Jupiter-Earth resonance. It appears our current configuration partially satisfies its condition. In other words, they could nudge it. And they did. After a precise sequence of M pulses and gravitational tweaks from Cairn's drives, the vault's outer layer softened and unfolded. Inside were data crystals. And a model of a star. The crystals were dense with compressed information. MNEM decrypted, Amira and Keiji interpreted. It was a memorial. Not for one object, but for a system, a star slightly more massive than the Sun. A rich array of planets. A habitable world that burned bright for a time, and then fell silent. The message wasn't in a language they spoke. But some things are universal. Graphs of stellar output over time. Climate data. Population proxies. Energy use curves. All of them rose, spiked sharply, and then plunged to zero. A whole star system civilization, documented through its astro-engineering footprints, then gone. The last entries in the memorial were coordinates. Not of that system. Of several others. KG zoomed in. They were clustered throughout the solar system. A point in the Kuiper belt. A small moon of Saturn. An object in Neptune's L5 Trojan cloud. A crater on the far side of the moon. There are multiple tombs throughout the solar system, he realized. The Trojan telescope was just one headstone. Over the next decade, the coordinates were checked. At each site, beneath ice or regolith or stone, they found artificial structures. Not identical. Not from the same builders. The Kuiper belt object, a tiny world of rock and ice, held a vault shaped like a dodecahedron, with inscriptions etched at atomic scale. The Saturnian moon site, in the crust of Enceladus, held conduits leading down to a deliberately warm pocket in the ocean, like an artificial hydrothermal vent. The lunar crater, permanently shadowed, cryogenically cold, hid a flat, glassy plate buried under meters of dust, its surface still carrying faint, regular charge patterns. Everywhere they looked, they found remains. They weren't colonies. Not bases. Not expansion attempts. They were markers. Each one described a lost system, listed a time of flourishing measured in stellar output, and an end, sometimes natural, gamma bursts, rogue planet impacts, sometimes not clear. And each one had one more thing in common. At the very bottom of each record, addressed to any who find this, was a rough sketch of the solar system. KG pieced it together first. These aren't their graves, he said. They're here because we're living in a quiet corner with unusually long-term stability. The Sun's orbit in the Milky Way is relatively circular. We're between spiral arms. We're far from the galactic center. Our system has no recent nearby supernova remnants, moderate metallicity, a Jupiter-class planet sweeping up some comets. Some researchers call regions like this galactic habitable zones, not just good for life that lasts. If you were a spacefaring species, losing your home, and looking for a place to leave a record, you might choose a system like ours. Not because we're special, but because our rocks aren't going anywhere for a while. Amira put it in blunter terms. The solar system is a graveyard, she said. Not just ours someday. A curated cemetery for civilizations that died elsewhere. Our asteroids, moons, and icy worlds were headstones and time capsules for dozens, maybe hundreds, of lost cultures across the galaxy. Each chose some stable nook in our system, buried a memorial, and left. Or died. Or transcended. We didn't know. We only had their last words, cast in physics and math and orbital diagrams. The third twist came from a site closer to home. One of the coordinates from the Enceladus vault pointed not to a moon or asteroid, but to Earth orbit. Specifically, a dynamically cold region in a high, inclined orbit just beyond geostationary. Old satellites gather there. Dead weather birds. Spy platforms. The bones of early space age. Kessler syndrome debris. Soren took Cairn in anyway. They had better shielding now. An object showed up against the clutter. A small, dark polyhedron, its orbital elements adjusted, century by century, to dodge debris. They brought it in, expecting another alien headstone. What they found was worse. Inside the polyhedron was a vault. Inside the vault was data. But the metadata, the way the data was tagged, encoded, labeled, wasn't alien. It was in an extended form of a human data standard, an archival schema invented in the late 21st century for deep time storage. The vault described a civilization from a small blue planet circling a G-type star. Climate graphs. Energy use curves. City lights blooming then fading. The end was ambiguous. The tag at the top made everyone on Cairn go quiet. Origin, Sol 3. Placement time, plus 6.2 mir, relative. For interment in Sol system graveyard. By request of local civilization. 6 million years from now is far beyond ordinary planning. Plate tectonics moves continents. Ice ages come and go. But if a civilization truly grasps stellar evolution, galactic dynamics, and existential risk, it might decide to plan its own memorial in advance. The polyhedron had a built-in propulsion system, tiny, efficient ion drives that would, over millions of years, nudge it from its safe orbit into a more stable frozen one in the outer system. Joining the other tombs. Our future headstone already in the queue. We don't know how that future plays out. Maybe humanity survives 6 million years. Maybe our descendants, bio, digital, or both, choose to deposit the vault. Maybe something else does it on our behalf. All we know is that someone, in some branch, expected us to end. And wanted us remembered. Just like the others. We set out to look for life. We found death instead. But not just oblivion. Memory. The solar system, it turns out, is not just rocks and ice and gas. It is an enormous, distributed archive, a graveyard where the dead write their own epitaphs in gravity and silicon and neutron scattering patterns. Mara, watching from her office back on Mars, put it this way. They were here before us, not on our Earth, but in our sky. They chose our backyard as their final resting place. We thought we were alone. We were walking through a cemetery and calling it wilderness. Finding tombs in your backyard changes how you see exploration. Every asteroid you mine might hold someone's last words. Every icy moon you drill into might be a shrine. We had to decide, do we treat these tombs as resources? As sacred? As case studies? Do we keep adding our own to the lattice, turning the solar system into a shared graveyard? Or do we dismantle them, erasing the scarred tissue of civilizations past? No law existed for this. We had to write it. In the end, the discovery that the solar system is a graveyard didn't tell us how our story ends. It told us something else. That across unimaginable distances, and unimaginable timescales, beings who burned like we do chose the same thing, to leave a mark. To say, we were here. We saw the stars. We tried. Our planets, moons, and forgotten rocks are their headstones. Someday, if we're lucky, one of them will be ours. And if another ship, from another young species, comes wandering through this quiet corner a billion years from now, and finds our vaults tucked into Trojan asteroids and shadowed craters, maybe they'll say about us what we now say about the others. They were not the first. They were not the last. But they did not go gently into the dark.